So x, and I've got -3, and I've got 3. I'm going to put this down here because I'm going to have more, probably. Might not. It's a really boring graph. I mean, it's gives only 2 points. Okay.
Yeah.
Then how am I going to find my critical points? I found those 2. I need some more. Some more would be the derivative, right? Where the derivative is 0 or the derivative is what? Is undefined not there? Yes. Okay. F prime of x equals 3x squared plus 4x. Great?
Yep.
All right. So far, good, so good? I'm going to find out places where it's undefined. Well, undefined, this is a beautiful function. This is defined throughout, right? It's a normal function we deal with every day. Not a problem. Where is it 0, though?
Where f prime equals 0.
Yes. So how do I find where it's 0?
You put f prime is 0, and then you.
How do I do a quadratic equation?
How do you do it? Or
Yes.
do you just do it?
Well, I could just do it, but the odds are you should know at this point that you could factor this. AB Central certainly thinks you can do that.
Okay.
And then you said each of the factors equal to 0, so x equals 0, and 3x plus 4 equals 0. Great?
Yeah.
And so I get 3x equals -4x equals -4/3. So when x is 0, we have a 0 slope. When x is at -4/3, we have 0 slope. So what do?
You put those in.
Put them on my list. I got x equals 0 and x equals -3/4. I like to put them in order because it makes my life better. Now, how do I find these are max or minimums, Mr. Dietz?
Wait, it's -4/3.
Oh, it's -4/3. Sorry, thank you. How do I find their max or minimums, Mr. Dietz? Nah, too vague. You can have a bunch of negative ones. You're going to plug them back in the original equation, get an answer, and then whatever it is, right? So I'm going to take my -3, plug it in there. Somebody plug in -3 for me.
-8. You're plugging it into the original.
Original equation, right? I want to know how high it is at that point, right? Or low. What'd you get?
-8.
-8. Love it. How about -4/3? So put that in the calculator. Let's go.
2 and 5/27.
2 and 5/27?
Yeah.
Love it. Plug in 0. I can do that. I got that one. I know. I always do. Plug in a 3. 3, I get 27 plus 18 would be 28 plus 18 would be 46.
Yeah.
All right. By the way, you can table it too if you're really desiring to do so. Yes, sir.
They always give you endpoints.
No. But, and by the way, that's a problem. Because when they don't give you endpoints, you forget they're there after a while. And then about the 18th time the problem appears, it's endpoints. And almost always, I'll tell you this little tidbit, almost always when they give you endpoints, it's one of the stupid endpoints. They literally are testing, do you know the non-calculus answer? And you're going to miss it because that's something you're not. The other thing I like to do is ask how many critical points do you have? And that's something that can throw you off too because you got to remember the endpoints. Okay. All right, so I'm looking at this. This is fun. Now what? What's the maximums? What's the minimums? At x equals -7, what do I have? At x equals -3, what do I have? There is a and, what would it be? And. And? What's the lowest point? -8. So this is the absolute minimum, right? Guaranteed. I've checked all the possibilities. Endpoints and slopes that are 0. That's it. Bottommost spot is at x equals -3 is an absolute minimum. At x equals -4/3, what do I have? There is a relative maximum. It's not the highest part, but it's bigger than all the rest. It's a turning around point, right? At x equals 0, what do we have? Relative minimum, right? It's going back down. It turns around there. And at x equals 3, what do I have? There's an absolute maximum. Okay? Now, how can we check this to see if we're doing the right sorts of things? We can graph it. Why don't you get your calculator out? Go ahead and graph y equals x cubed plus 2x squared plus 1. See if we have these maximum minimums that we're talking about. Remember, we're starting at -3 and ending at 3. So if you want to bound your graph at -3 and 3, go ahead and do that by you bounding your window that way. You don't know how to do it, just pretend like it starts at -3 and ends at 3.
Would it be appropriate for those points that are neither to write them as so?
To write what?
Like, for example, on the right one, C and D as neither.
C is a neither. D is actually a relative minimum.
G and
G is a neither, yes. They're asking you to, that's an interesting question. Determine whether each label point is an absolute maximum minimum. They're not even points technically, so technically G you would say, it's a bogus question. I refuse to answer that on the grounds it's not actually a point. But C is a neither. C is a neither. What would E be? Compared to the two directions, is it what? To the top of the hill or the lower? You're making this way too hard, Mr. Wilderman. Am I on top of the hill or the bottom of the hill?
You're on top.
I'm on top. That makes me a relative maximum. Is it the highest hill?
No.
No, so it's relative. Yes, sir.
Even though G is not a point and it is an endpoint,
Yes.
it is still higher than anything else.
Yes.
So that means that B has to be relative.
B is a relative maximum. You got that correct. And G is not the absolute maximum because no such thing. Even though there's a point right next to it, well, but we don't count that. Because we have no point there. Yes?
So this is like a graph that had a equation for it, and we would find the absolute maximum. It's like this right here.
Okay. If it was a curved bracket, the answer is there is no absolute maximum. Even though you and I can both agree, there has to be a point right next to it. What is that point?
Don't say if you have the equation to figure that out.
Right, but the problem is, if I say, curved bracket over here, 3, what number would you put in your equation? 2.99? 2.999. 99. No, that's the problem. The problem is you're now talking about a maximum where you can't define it. So the absolute maximum would be undefined. That's really what we're looking for. But we'd say it does not exist. Okay? Because that's what AP7 decided to do a long time ago. Whether or not that's a legitimate, does that bother me sometimes when I think about it really hard? Yes. There's 2.999 repeating is the correct answer. It is. That is absolutely where it is. There's an absolute maximum there. But they would say, yeah, but. Okay? And so you'd have to go, okay. Well, I'll bow to the people said. Now I will tell you this: they don't want that discussion. So what's the odds they're going to ask for an absolute maximum where that is the absolute maximum? They're not going to. They might ask you find all absolute maximums or absolute minimums if they exist. Period. And then you'd find the minimum, and the maximum would not exist. Does that make sense? Now you would check 3. Because it's a critical point, and you still count as a critical point. But when you check 3 and it becomes the highest point, then you go, okay, it does not exist, so therefore I can't use that point. They would expect to see 3 on your critical point list, which is interesting. Okay, but they would expect you to do that. Now again, that's inside baseball. We still haven't done any of these problems, so we're talking about problems that are coming up. A worksheet we're going to show from now. Yes, sir.
So for the critical point list, do we only put the value of x or we put the full point?
We put the value of x in, and then when we go to figure out what the y value is, we just plug it in our original equation and get our y values, and we're at the list of y's right next to it.
Something like asks you for your critical point, you will put like the full.
They will not ask for critical points. Instead, well, they will. Sometimes they do. Usually what they're going to say instead is they're going to say find the maximum minimums. And you need to know that if you don't check critical points, they're not going to give you points for it. You're going to lose that point for not checking critical points. Even if you check them all. If you check every single, if you do list them all, by the way, in some sort of random order over your whole entire paper, straws. If you do that, then if they're all there, they'll count it. But you're much better off writing a table, because even if you look at one, well, that's clearly not that one. If it's on the table, they know you considered it.
Okay.
If it's not on the table, they don't know if you did or not. If you look at, if you got a graph that starts here and then something like this, and you know it does because it shows it on the above, and you don't consider that one and that one, you lose that point. Even if you're pretty sure they can't be. You have to show them that you considered it, that was a possibility. And it's not as stupid as it sounds, because I can tell you the number of times people have missed the obvious because they say, well, that can't be. And then you plug in the equation and go, whoa, surprise, it is. And so it's okay to do this. It's okay to do the little monkey, I'll do this, I'll write down the critical points, even if I'm not going to check them, because I'm pretty sure just look at the graph, they're done. Okay? Probably better safer off now. Try number 3. Number 3 says, find the derivative of the indicated function at the point indicated. It's taking a really long time. What is it, Sax? 0. Well done. Whew, that was a hard problem. Let's try number 4. What's the slope of those 2 points that are indicated? You can do it, by the way, if you'd like.
But it's 0.
It's 0 and 0. Got it? Get the game? What's a slope at 5?
0.
Do you guys want to do that one? Slope is 0. What's a slope at 6? Oh, there's 2 points there. Careful. What's the slope at the left-hand point? Undefined, right? If it doesn't have a left side, you can't describe its slope, right?
Would 8 be a point to point across?
8 sure looks like a pointy point to me in the middle. The slope coming to the left and the slope coming to the right are not the same number.
So endpoints and pointy points.
Pointy points, yeah. If you see it on a graph.
And then just maximum or maximum.
Those are what lead to maximum minimums, right?
That's what it is.
Slope 0 or a pointy point. Like if you look at number 8, the maximum is clearly at 0. X equals 0. Yeah. And that's because of the pointy point there. The slope goes from one slope to another slope without transitioning through 0, which is where we want it to transition through.
Are they all zero?
No, number 6, the left-hand one is undefined.
But besides that.
Also, the one on number 7, that's clearly undefined. Notice how it's bouncing. Looks like a pointy point. I mean, if you want to solve it, you can. Let's do it. You want to do it?
Yeah.
Is number 8 undefined?
8 is undefined, yeah. Slope from the left and right are 2 different answers, right?
Do they have enough?
Well, okay. I want you to find the slope of this. What's going to be the difficulty at this point here? If my slope from the left and right are not the same, I can't find a slope. If it's something that looks like this. Yeah, a slope going from this side looks something like this. A slope from this side looks something like this. Those are 2 different slopes, right? Anything that's sharp and transitions there, if you do the equation, you're going to get it defined. By the way, if you look at the top equation, I'll do it really fast. 40 is at 7 at 7. If you do the slope, you're going to get 2/3 x plus 2 to the negative 2/3, right? To negative 1/3, sorry, times the derivative of the inside, which is just 1, right? That, it becomes undefined because it's 1 over. It becomes undefined when x is equal to 2, right? Or negative 2. So the slope becomes undefined at negative 2. So the equation, the derivative, would give you an undefined slope there if you bother to try it. Does that make sense?
Yeah.
That really makes sense, because if it doesn't make sense, we need to play with it some more.
Yeah.
Yeah. Okay? All right. All right. Number 9, find the critical points by inspection only.